Hello, students. Now we are going to discuss about SHA-512 algorithm. In the previous sessions, we have gone through MD5, MD family algorithm, where we have seen MD2, MD4, and MD5. Then we have moved with the Whirlpool algorithm, where we have utilized AES algorithm in that. Then we have seen the SHA family versions, SHA-1 to SHA-3. Now, in detail, we are going to check about SHA-512 algorithm, where this algorithm is having n number of applications like digital signatures, where we can ignore deduplication of the data, and also we can verify the passports with this, and we also can check the integrity of the message. So these are the few applications of SHA algorithms. Now we are going to see what is the working structure of SHA algorithm exactly, right? Now let us move with the SHA-512 algorithm in detail. Here we are going to see the outline with the SHA algorithm introduction part. Then we will be seeing the functionality, including few steps of the algorithm with one of the diagram also, where we can see the top view and also the internal structure of the SHA-512 algorithm in depth. Okay, then in the SHA-512, we have two major important parts such as padding part and also having 80 rounds of operations with the compression function. So thus the last two points are discussed with the theme of padding and also the compression function. So let us move to the introduction part, the outline part of SHA-512 algorithm. Here SHA-512 algorithm, the message digest is of 512 bits. And what may be the size of the message? That size of the message must be less than 2 power 128 bits. Okay. So whatever the message length it is, it must be, first point to be checked is the message must be less than 2 power 128 bits. Then after taking the message, we have to divide the message into blocks of data. So where each block will be holding 1024 bits. Now, each block of data will be given to the compression function, where this 1024 will be called in 16 words format. So 16, one word will be taking 64 bits, thus it will be making 1024 bits of block size, right? So this is the first point. And second point is knowing about the block structure. Third point is, as we are saying SHA-512 bits will be the size of our message digest. I mean the output of every block will be called as a message digest, where we call the output of every block as an intermediate message digest and the final outcome as a final message digest of SHA-512, right? The fourth point which we should know about SHA-512 is the number of rounds it will be taking. So 80 rounds of operations will be performed on every block of 1024 bits. Every block of 1024 bits by converting 1024 into 16 words format. Okay. So this is the basic intro part of our SHA-512 algorithm. Right now, let us see its working. So how major, like already in the previous session, we have seen the top view of SHA-512. Now we are going to discuss in detail about the working of the SHA-512. Here the SHA-512 will be taken with n number of bits. So the message size may be anything, but that must be less than 2 power 128, as we have mentioning this a number of times, but we should remember that that must be less than. Then after taking your message, you just convert that message into multiples of 1024 bits. If it is not a multiple of 1024 bits, you just pad extra bits to make it multiple of 1024 bits. In this multiple, the whole multiples of 1024 bits, we should also include the length of the message that is stored in 128 bits. So after adding 128 bits and after adding your message and after giving some extra padding bits, okay, extra padding bits and your length, it must be multiple of 1024. So you have to convert into multiples of 1024. So let us suppose I have 6 into 1024. So how many blocks of data I'll be getting as 6 blocks. So I'll divide each block with 1024 so that I will be getting block 1, block 2. So like that I'll be getting block 6. Got it? So that is the reason we have to convert that into multiples of 1024 for sure, because every block in SHA-512 will be 1024 bits. So that is the reason blocks must be 1024 multiple. Now, after converting this, just you take every block of 1024, convert that into 16 words format, give to the compression function. So while I am giving this to the compression function, I should go with the H0 functionality also. Means I am padding with, I am giving with H0. So what is H0 here? 512 bits of data, right? So this 512 bits of data, I mean the hash function, I mean the 1024 bits you give to the hash function. Now this hash function will be giving us 512 bits. This 512 bits and this 512 bits, we are going to perform XOR operation. XOR is performed when two inputs are same. So that is the reason H0, I mean IV is the initial value. See, initial value, where initial value will be holding first value as 1 and remaining all 511 bits will be zeros. Got it? So take this H0 and give to the output of your M1, I mean the block 1 output 512 bits. This 512 bits and this 512 bits, you just perform XOR so that you will get H1. So H1 is a message digest of M1. Now, before moving to M2, we should store this 512 bits as the XOR operation for M2 operation. See, M2 1024 bits, you carry forward to the compression function, and compression function will be giving us 512 bits of data. This 512 bits of data, you perform XOR with the output of the message 1 block, that is H1, you will be getting H2. So this is a repeated process till N. So if I have 6 blocks of data, after 6th block, I will be getting the final hash code that is called as the message digest of SHA-512. So this is a procedure we follow for SHA-512. I mean, this is a working structure of 512. Now, these are the few steps we are going to follow in the working structure of the SHA-512. So what is the first step? We are going to padding the message first. So why we need padding? See, we are saying whatever the message length we have to convert that into multiples of 1024. Yes. So to make it a multiple of 1024 whole message length, it must be multiple of 1024 after adding 128 bits, which is storing the length of the message also. If we are lack of few bits, we are going to pad extra bits. We are going to pad extra bits. So for that purpose, we need to pad the message. Okay. So after this, you pad the message, then set the initial values, that is the IV values, initial vector or initial values as a H0, and then you process the each and every message block of having 1024 bits, provide to the compression function, and compression function will be giving us 512 bits. Now, update the hash values where I am in the message block 1, I should utilize H0. When I am in the message block 2, I must utilize H1. The output of M1 must be utilized as a H1 to be utilized for M2, right? So if this goes on repeating, when I am at I-1 position, I will be operating MI block, okay? When my hash value is at hash of I-1, I will be at MI block. Got this? So after a number of operations, after multiples, right? So if I am at the multiple of 6 into 1024, after 6 times, after 6 outputs, that is M12, M6 output. Whatever the value we get, we call that as a final hash value. Okay. And every time we are saying we are providing to the hash function, right? So this hash function will be called as a compression function, right? So we are going to see what is compression function once again in the next session, right? So we have seen here, right? Just now we have seen here, in between we have compression function. See the function which we are highlighting here is the compression function. This we have to see once again in detail. So let us go and check with that in the next session.